All right, now on to our last section of Unit 4. This is called translating graphs. What that means is we need to learn and know, like the back of our hand, a parent graph, and then we can instantly draw any other graph from an equation that's given to us. I know that sounds complicated and weird, but don't let it worry you. I'm going to show you exactly how to do this, and it's kind of cool actually. So if I have y equals x squared, in 121 you will see this as f of x equals x squared, or f of x equals whatever. Okay, just know that the f of x is really just a y in this case. Okay, so if I needed to graph this thing, about the only way I know how to do it at this point is to make a table. So x and y, remember these tables and how to graph with these? So I'm just going to start picking some numbers. I'm going to say let x equal 0. So if x is 0, so I get y equals 0 squared. Well, 0 squared is 0. So that means y is 0. Let's say I'm going to pick 1. So if y is 1, 1 squared is 1. Okay? So, excuse me, if x is 1. So then let's say if I pick x to be negative 1. I'm just randomly picking these. Okay? So if x is negative 1, that's equals, then negative 1 squared is 1. Let's try a couple more. So if x is 2, this has to look like an equal sign. 2, x is 2. 2 squared is 4. Let's try negative 2. If x is negative 2, then negative 2 squared is 4. Let's try another one. How about 3? If y is 3, if x is 3, sheesh, just can't talk and write at the same time. If x is 3, then 3 squared is 9, so that's what y is. If x is negative 3, negative 3 squared is 9. And I can keep going forever. If x is 4, then y is 16. If x is 5, then y is 25, etc., etc. And same with the negatives. Okay? Now, when we are doing graphs, we are going to do the work for the graph on regular paper, and then we are going to do the graph on graph paper. So I'm going to go ahead and graph this. Please write down this table, the x and y table, so that you can see when I'm graphing this that we are doing it, or I am doing it correctly. Okay, so we make a y and an x axis here with a ruler. Okay, always put arrows on every single line. That means that that line is continuing in that direction forever. We are always going to label our x-axis right out to the right and our y-axis up at the very top. Okay? If you do not do these things, I will take off points. Please put your graphs in the middle of the paper. And if you have your holes over here, put your number somewhere in here of the problem. Okay? Otherwise, I won't be able to see it. All right. So now let's start this. We had 0, 0. We had 1. And when x is 1, y is 1. When x is negative 1, y is 1. When x is 2, y is 4, 1, 2, 3, 4. And when x is negative 2, y is 1, 2, 3, 4. When x is 1, 2, 3, y is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when x is negative 3, y is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can keep going forever. So now I'm going to draw this, connect my dots, put arrows on this because these keep going in each direction forever. And then I'm going to label each of my points. Okay, all of my points must always be labeled. Oops, not one. Ooh, somebody caught that. I just feel it. I'm so glad. Okay, so get out some graph paper and graph this as well, because as we're talking, you're going to need to be seeing this, okay? So what we're going to be doing now, I need you to understand that this is the parent graph. And we have many different kinds of parent graphs. So anytime we have this, a quadratic equation, our graph is always going to look like some kind of a horseshoe. You know, something like this. Maybe it goes wide, maybe it goes this way, but always some kind of a horseshoe. Some of the other kinds of parent graphs that we have are things like y equals the absolute value of x, or f of x equals the absolute value. Well, this always looks like this. It might go the opposite direction, it might go this way or whatever, but it always looks like a v. We can have y equals the square root of x, and this one always looks something like this. Again, it might go the opposite direction, all kinds of things. We could have y equals, say, the cubed root of x, and then that would always look something like this. And we could have something like y equals 1 over x, and that would always look something like this. Oops, that's too high. Like this, because if this is our x-axis and this is our y-axis. Okay, so you don't need to learn all of these yet. When you get in 121, you'll need to know them. But what we are going to be talking about is translation. How to take an equation of this guy and be able to graph him instantly without doing a table. So are you listening to me? If you do a table from now on, after we learn this, I will take off points, okay? But the thing is, translation doesn't always apply just to this. It applies to this one, and to this one, and to this one, etc., etc., etc. So once you learn translation, all you need to know is how the parent graph looks, and then you can draw whatever graph you get. So in the next video, I'm going to go over the rules of translation. And in the video after that, I'm going to just do some examples. Okay?